Welcome to The Cynical Developer, the podcast that helps you to improve your development knowledge and career through explaining the latest and greatest in development technology and providing you with what you need to succeed as a developer. In this episode, we talk to Daniele Pozzobon about test-driven development. Daniel is an aspiring software craftsman with more than 10 years of experience in the software industry. He is currently a consultant in the .NET space for a big insurance company and previously worked in the manufacturing industry. He has experience with C#, Java, C++, PHP, JavaScript, and lately has added some F# to the source. He constantly annoys his friends by talking about software and is passionate about agile methodologies, which gives him more opportunities to annoy his friends even more. When there are no friends around to annoy, he blogs on Clean Coders, and in his free time, he loves going hiking with his wife and his 2 daughters. So welcome to The Cynical Developer, Daniele.
Thanks to be here. That was a nice cover of myself. I'd like to add that I'm a Cold Wars geek. I like to spend a lot of time there, and your audience should go there too, because that's a pretty nice site. And if you hear me, my pronunciation is more like Super Mario Bros. That's because I'm from Italy, so yeah. That's the reason.
Yeah, sure. Code Wars is really good. It's something I've not been to for quite a while now, but I did spend a little time on there playing around with the code carters and things on there. It is really good to get your skills honed.
Yeah, and now they added also F#, so that's amazing. They have every language there.
Yeah, so you've got C#, Java, C++, unfortunately PHP, JavaScript, and F#. So you're busy and doing a lot of different languages.
Yeah.
Do you do them all the time, or do you mainly do one over the other?
No, now I'm not focused on C++ and PHP. Those are from the past, and also Java. Now I'm focused only on C# and JavaScript for work, and a little F# when I have time.
Yeah, it's a lot nicer over in the C# world.
Yeah,
I've done a little bit of Java in the past, and I don't know why, but it's not my favourite. But I don't want to be too biased, because we have some Java listeners on here as well.
Yeah.
So I don't want to scare them all away and annoy them. So today we're here to talk about test-driven development, or TDD. So we'll get in straight off the bat with an easy one for the people that don't know what TDD is. And what is TDD?
Oh, okay. So let me play a professor here and just swap around this interview for a moment. I'll ask you a question. Let's say you have one requirement to implement. You have to implement some method that places orders. The method has some inputs, and it saves something to the database. It manages the data, and then sends an email that maybe says, okay, the order was placed. How would you write an implementation for this if you do it normally without tests?
I'd probably just write the code and do a bit of simple testing of actually running through the whole of the process. So from placing the order and then checking my email address account to make sure the emails have come in, and that's probably about it.
Okay, and if you find something is not working, how would you address it?
You'd have to step through that in Visual Studio, debug it, and keep running through it until you find out what was wrong.
Oh, okay. That's normally what we do every time if we are not doing TDD. But people still doesn't know what TDD is, so let's go over. Let's say you have a pretty complex implementation to do. You maybe do some sketches right before starting implementing. So Now you have the sketches done before implementation, and maybe you did the implementation, you run it, and you want to ensure that the implementation stays in the future correct. So you write some tests probably afterwards.
Yeah, that's pretty much how my testing goes. I always write them after the fact, which I know for this is the wrong way round.
Not wrong, but it maybe is more difficult. The point is the point that I'm trying to make is that you did some sketches before, and then you maybe wrote some tests afterwards. But what if I say that you could have written your specification in a way that you could run them, and the computer would have said to you that the test that the implementation was correct. So, for example, you don't start writing your implementation. We are coders, and we like to write code, so we run fast and write the implementation. But you keep calm, and you write your specification as a test. You write those tests, and then obviously all the tests fails. So what do? You start writing your implementation, and slowly your tests start to pass, and that's called test first, when you write first your test and then you write your implementation. So back to your question, what is TDD? TDD was proposed by Ken Beck in the Extreme Programming book, Extreme Programming Explained. He was working with his team, and they had the permission to do a lot of experimentations. And one thing they noticed is that they could translate the specification as test and then pass the test by writing the implementation.
Right. So before you actually sit down and you write any classes or you do any methods or anything like that, you take your specification, you look at all the caveats that are in there, and then you write tests around them to prove that they work.
That's right. And you prove that they work when all your tests are green. That means that you covered all the specification. What they experimented later was to reduce the cycle between writing a specification, translating a specification into a test, and writing the implementation of this test. So by reducing a lot this cycle, they discovered this procedure that now we call test-driven development. So in test-driven development, you write a little test that fails, then you write the implementation of this test that make the test pass, and then you clean things up. But I think this will be clearer later.
So with test-driven development, you mentioned that the computer or the build server or whatever is testing the code automatically for you. What's the benefits over test-driven development compared to traditional testing with people that are actually just going through the processes on the system?
Okay, so how many times do you have to have you been testing your application and you had to log in and then click a bunch of menus to then go to the part that you want to test, run your test, and then it doesn't work, you do some new implementation, and then you start all over again, logging into the system, and etc. etc. Testers normally do this all day. They write a script and they go manually over that script, something that the computer could do easily. Some improvement on this procedure would be the automatic test over the user interface, and some advantages is that the tester doesn't have to run manually over the script, but there's an automatic script that does all this work. The problem with this test is that they are slow, and you can run some of them during a cycle of implementations. And when the tests all pass, finally you have the permission to go to production. But what happens to the code then? Nobody has to touch it, because if you touch, at least in my experience, the code that was already certified by some manual test, you should rerun all those tests, and the tester wouldn't be happy about it. So having a lot of unit tests that TDD gives you means that you could run all these tests automatically and in a faster way, because unit tests are fast by definition.
So it's making that testing process more efficient, and also, whereas if the manual testers were they were running through their tests, just because they're following scripts doesn't mean they're going to do it exactly the same way every time.
Exactly.
So with coded ones, they're done exactly the same way every single time, and they're run in sub-seconds rather than minutes. So you get more reliability out of your code from that.
And those poor testers could be using their time to do better things, like discovering in real integration problems and doing some smoke tests.
These tests that are being run, they're created by who? Is it the developers? Is it the test team? Is it somebody else? Who in the team creates these unit tests?
The process of working in TDD is to write the test before, a little test before writing your unit test, your production code. So the tests have to be developed by the developer, but have to be written by the developer, and the developer have to prove that his implementation works. I have seen many times people that just write some implementation of some feature, and they throw it to the QA department without even running the test manually, and that is not acceptable by any means. And test-driven development prevents you from doing that. And moreover, writing this test gives you a lot of confidence in your code, because you always are in a green state, meaning green that you have your test passing, and you then can improve the quality of your code by refactoring and maintaining your test in a green state. Then the tester, after writing this test and finishing the implementation, can check in the implementation and the test, and if there is some kind of continuous integration system in place, it could run the test of all the system, and this means that every time someone writes the test, all the system could be tested that is working.
It protects you against making a change and you not thinking of a certain scenario, and the tester's not thinking of a certain scenario, and then that getting through to live, because every scenario or every possible outcome should be covered by those tests.
Yeah, that's if you are working in TDD.
I mentioned there that code being covered by tests. Now, there's something called code coverage in unit testing. Could you explain what code coverage is?
Well, code coverage is a really strange metric. Why it's strange? Because it shows you the percentage of lines of code that are executed by a test. It doesn't mean that the line of code is actually tested. You could easily write a test without an assertion that the execution is correct, and your code metrics would get higher. But you normally won't do that. If you are working in a TDD world, you actually are writing your tests before you write your implementation, so that would be difficult.
Right, so it's a bit of it's a false metric really, because it says that this bit of code is tested, but those tests that are there don't necessarily cover all the requirements, and maybe they don't even really test that code.
Yeah, let's say that code coverage gives you a percentage of confidence of how easily you could find a bug, if a regression, if you touch something. For example, you have code coverage of 85, and you're pretty sure that if you find some parts of your code that are touched by a test without changing those tests would fail.
So you mentioned about 85% there for code coverage. What's a realistic code coverage to aim for? Should you be looking at having 100% of your code covered by unit tests?
So UncleBot says 100%, because if you are doing actual TDD, you shouldn't have any line of code that is not tested by some tests. Every line of code should be instantiated by a test. So that means that you would absolutely have 100% of coverage. But in a realistic world where you are not always working in TDD, you would have lower code coverage. And normally people talk about 70 to 85% being a really good code coverage.
So if we're covering all our code with these unit tests through TDD, is there still a need for manual testing? Does the QA or the test team, do they still have a job if you're doing TDD?
So making a lot of complex software work interconnected could be difficult. There are a lot of things that could go wrong that TDD doesn't cover. One example could be load testing or some complex implementation on UI, on the user interface. So yeah, I believe that testers still have a place in the game, but they are not required to do some work that a machine could do better and faster. I'm not an expert on testing, but I know that there are some procedures like smoke testing that give the tester a way to break software and find a lot of edge cases that maybe are not covered by unit tests because are more about the interconnection, interdependencies of the software.
Sure. So your unit tests that you're writing, they cover the eventualities that are in the specification, but if there's something in there, there's something that happens that isn't in the specification, your test will never find that, and that would be down to the human that sat there typing away on the keyboard and on your application to actually replicate and find and give you some feedback as to how to fix that.
Yeah, and the tester also are really good at simulating the user, the real user, and we developers aren't. So thinking about different things that the user could do and that we didn't cover in the unit test because we are unable to think like an user.
You mentioned Uncle Bob before, Robert Martin, but he outlines 3 rules for TDD. I don't know if you're able to walk us through them and the ideas that are behind each rule, because the first one he talks about is you're not allowed to write any production code unless it is to make a failing unit test pass.
Oh, so let's run them through them quickly, and then I will summarize. This first one simply means that you are forced to start by writing unit tests. You cannot write any implementation before you write your unit tests.
Okay. So the next one is you're not allowed to write any more of a unit test than is sufficient to fail. and compilation failures are failures?
Okay, so if it doesn't compile, you stop. So why? Well, this. The point is that making software compiling could be enough of an implementation for a test. You could probably write a test that only requires that a class is instantiated, and if you write more tests other than just making the thing not compiling, you would be writing superfluous tests, redundant tests, superfluous code in the test. More importantly, just writing a failing unit test means that just one assertion, not two assertions, just one, because again, you don't want to write redundant unit tests. You want to concentrate only on one simple case.
So you're saying that you shouldn't have more than one assert at the end of a unit test.
Yes, that to me doesn't actually mean one assert. There's some controversy obviously on that, but one assertion is to some in the TDD world that you are asserting, for example, that an object is correctly instantiated, so all its properties are correct. That would require more than one assertion in the test.
Sure.
But you are asserting one thing.
So the last one on the third one is you're not allowed to write any more production code than is sufficient to pass the one failing unit test.
Okay. Now you have a failing test, and you have to write an implementation for that test. As soon as you write that implementation, you should stop. Why? For the same reason that you stop writing the test. You don't want to write unnecessary production code. If I write some implementation without test, I'm actually writing some implementation not covered by my specification. This time the test is my specification for the implementation. So why writing production code for some specification that I don't have?
So that sort of that extends the you ain't gonna need it sort of mindset as well. That
yeah, that's right.
If you don't need it now, don't write it. Write it later on. But would you still write the production code in a way that it could be extended later on, or would you just write it that it just worked for that one unit test?
The general rule is to write the minimum amount of code that is required to pass the test. And for example, you have a test that asserts that a method called return add 1 + 1 returns 2. The implementation of that test should be return 2. But that's ridiculous, you could say. The point is that you write a bunch of these tests, and slowly you come to the conclusion that you need some generalization. And this is called triangulation. And by adding more and more tests, you notice some duplication on your code, and then you start to generalize your code, so you have a better code and more general implementation.
Sure.
When you don't find any test that can make your code fail, that means that your code is sufficiently general, but still you are not writing code that is not going to be needed.
Yeah, I think it's a slightly different mindset to other ways of working, because I think I would look at a problem and think, well, this provider, maybe it outputs something to a text file. It may need to output it to a database. It might need to output it to an email, and it might need to send it via SMS. Outside of the TDD world, I would probably go and implement that straight away, and maybe not put all the code in there for the SMS and for the database and everything else, but maybe I'm just working on the text file one, that I would stub everything else out for the SMS, for the database, for the email, but just write all the production code for the text file. But what you're saying here is that you wouldn't even do that. You would just leave it at just doing the text file, and later on you would come back to it and you would add the SMS, the database, and the email functionality.
Yeah, almost correct. Because you would probably write that implementation to an interface that is your external dependency, unless you are writing the implementation that physically writes the file.
Okay, so we were talking before about different assertions and how many assertions should be made. What, at least in your opinion, makes a good unit test?
I was talking before about that unit test could be run a lot of time, more than manual tests. That's why one of the more important things is that unit tests are fast. They run in memory. They don't use external dependencies. Why is that? Because they run in isolation only the class, let's say, business logic of the class. So, for example, you have a system that makes some calculation on some data and then saves the result to the database. Okay, you don't use a database. The database is a pluggable system to your business logic, and the unit test runs only the business logic and asserts that the database is called in the correct way. That way you are isolated to the slow part of a system. Another important aspect is that they should be simple and maintainable. If you find tests that are difficult to understand or maybe difficult to set up, maybe that's a smell that your system needs some refactoring, because you are probably working on classes that are too tightly coupled one to the other.
So you've got to have separation of concerns in there. Your unit tests have got to run quickly and they've got to run in isolation. So you spoke about making the database pluggable. How do you make it pluggable? In your unit test, do you have to create a new version of the database that maybe implements the iDatabase interface that you're using? Or is there something out there that can actually help us to achieve that?
So you could use, for substituting your database, what we call a test double. Normally people call them mocks or mock objects or fake objects, but the correct term is test double, and you can find information about them in XUnit patterns. I will give you the link, and also in my blog. So test doubles are implementations that are different from the implementation that you use in your production code. They're only used in your test code, and they are there to simplify your dependencies, the dependencies of your system. So in my example before, you have a database, and in your production code you actually call the database via probably a repository. In your test, your repository doesn't connect to the database, but sends all the queries to some class that implements the iDatabase, interface, and your repository talks to only the interface of a database.
Yeah, that makes sense. Makes that a little bit easier to understand, because that's always been one area that I've been a little bit confused with how you would test, is that I would probably just mock out that database and have it return lists and arrays and things as to what I was expecting. You're not actually testing the database itself, really.
Yeah, you actually shouldn't test the database itself, because it's not your work, it's not your job. The database is an external dependency and it's not under your control. You shouldn't test that it's working correctly. You shouldn't, for example, test entity framework. Should you write unit test? Would you write unit test to test entity framework? I don't think so.
It's not your code, so you don't need to test it. I guess that sort of falls into my next question, which is, there's something called integration testing as well. Does that get covered with TDD? And if it does, what's the difference between unit testing and integration testing?
Okay, so every time I'm asked this question, I always like to start some controversy by telling people that integration tests are a scam.
Right, okay.
No, so really, integration test, that was an article written by the Code Whisperer. His name is quite difficult for me, but his Twitter handle is jbrains. I will give you the link to the article. It's a really interesting and smart guy, and he says in the article that integration tests are too difficult to test completely. But what is an integration test? So we were saying that unit tests are tests of the classes in isolation, of your business logic in isolation of every system. An integration test would be run with part of the system, being that other classes or probably the database. The problem is that this article writes about is that you have a lot of classes working together, so the number of paths that you should test grows exponentially. So it's almost impossible to test completely with traditional tests or test them in integration.
Yeah, the name of the guy I think you were referring to there was J.B. Rainsberger.
Okay, that guy. Yeah. For me, the surname is quite difficult.
Yeah.
Says.
We've talked a lot about testing what is essentially back-end code. Is it solely available for the back-end, or can you do UI testing as well through unit tests?
So, actual UI testing, I don't think so, because UI testing probably focuses on the colors and the position of the items in the browser. But there are some people that likes to mock out everything and try to test just the UI without any logic underneath it. But with modern frameworks like the MVVM frameworks and the MVC frameworks, you could go really near the user interface and test almost everything, and you leave to the framework to position correctly the data in the UI, and as we were saying before, you don't test that the framework works correctly.
Sure, you sort of leave that down to the QA team and the test team to actually get in there and do that. That's one of the jobs that is still left after after TDD that they need to do.
Yes, they could write automated tests, but I don't have experience in writing unit tests for the actual UI layer. You could, if you have some logic on your UI, for example, with JavaScript frameworks, you could write tests for that too. So, for example, you could use Jasmine or QUnit to test your UI layer, the logic that is in your UI layer.
So I'm all out of questions. So I'll take this opportunity to thank you for coming on and describing TDD for us and giving us a little bit of a better insight.
It's just a mental shift. You should start by taking some katas. Of course, you don't start by doing it on your production code. Start with some katas, with some simple one, maybe some problems in code wars, and you will find some pretty amazing things if you try it.
Sure. Well, we'll include the links to Code Wars in our show notes. I'll also link through to the rules that we talked about for TDD by Uncle Bob and everything else, including Daniele's blog. Thanks, Daniele, for coming on and talking.
Thank you.
So thanks for listening to The Cynical Developer. I've been James Stoddart. You've been listening to Daniele Pozzobon talking about test-driven development. If you enjoyed this episode, please leave a review on your favourite podcast platform and help The Cynical Developer to grow by increasing its audience. If you have any questions about this or any other episode, then drop us an email, a tweet, or leave a comment on the website where you can find all the resource links and show notes for each episode.